All right, we're used to seeing carboxylic acids act as an acid. It's in the name. But all of these types of carbonyl compounds, if they interact with even a stronger acid, they could actually act as a base. The stronger acid is going to give up its proton. So if we had any source of a proton that was a stronger acid than a carboxylic acid, that will force it to act as a base. But that brings up the question, which oxygen is going to be more basic? Both oxygens have two lone pairs of electrons, right? So is A going to be more active as a base, or B going to be more active as a base? So which one's going to be more basic? And it turns out that we evaluate basicity kind of in the same way that we evaluate acidity. We look at the stability of the conjugate. In this case, we're dealing with a base, so in this case, we're looking at the conjugate acid's stability. So why is that? Really, we're bad at evaluating things that aren't charged. This base is neutral. This as an acid is neutral, so we can really evaluate how stable it is as a conjugate base if we look at the charge of that. We saw that in the last video, it's negatively charged. If this protonates, it's going to be positively charged, and we can evaluate the stability of that conjugate acid based on the stability of that positive charge. So the more stable conjugate acid came from the stronger basic position. So the more stable conjugate acid came from the stronger base. The stronger base. So just like the stronger acid generates the more stable conjugate base, the stronger base generates the more stable conjugate acid. So it's kind of saying it in reverse. The stronger base, once it grabs a proton, generates the more stable conjugate acid. So it's the same situation as we are used to seeing with the acid, but it's just now we're looking at the base. So what happens if we protonate A versus B? So if we do A, I'll do that in this marker. We would protonate that. We'll extend this and say A would provide us with this structure here. And if we protonate B, this marker kind of sucks. Maybe we'll do green. Let's see how that works out. Yeah, that's better. So if we protonate B, we would generate this structure. So that's when we protonate B. So which one's more stable? Is this conjugate base, is this conjugate acid more stable, or is this conjugate acid more stable? Because the more stable conjugate acid came from the stronger base position. So is this more basic or is that more basic? So pause the video for a second. Evaluate these for their stability. Think about all the things that we always think about when we're evaluating conjugate bases for stability. It's the same kind of ideas. It's the same kind of ideas that we saw in the last video. So try to figure that out. Which one is more stable, A or B? And you might have to draw some more structures to do that. All right, you've paused it. You're back. All right, hopefully you said that A is more stable. Why would A be more stable? Well, what stabilizes charge? Delocalization. How is A delocalized? Well, we can pull up the electrons from that pi bond. That would generate this structure here where the positive charge is on that carbon. We can also move over those electrons to even draw a third resonance structure. So when we protonate this oxygen, we actually have a mixture of three resonance structures showing that that positive charge is delocalized over multiple locations. This B protonation only provides this one structure. It is not delocalized at all. So there's no delocalization there at all. So that would be why we can say that A is the more basic position. So where is this going to come into effect? Really, this acid-base chapter 19, is setting us up for a study of carbonyls in general. And it turns out that we can take a carboxylic acid and treat that with specific reagents to make an ester. And the mechanism of how that occurs very much has to do with this idea of what's going to protonate first, how is it going to work. So this will be even more important in future chapters. And we will continue our discussion of acids and bases soon.